Hello and welcome to our webinar. It's great to see so many of you joining us today for what promises to be an interesting session. Today we're going to be exploring some of the challenges and opportunities facing the renewables sector in the UK and how many leading organisations are overcoming these with a geospatial approach. Just to let you all know, this session will be recorded and we will make sure it's available to you after the session. So my name is Jessica Allen and I'm Head of Commercial Markets at Esri UK. In a moment, I'll hand over to the team, starting with Dominic Linley, our Renewables Energy Lead. Dom will then be followed by Dave Tong and James Noble, who are our Customer Success Consultants. So before we get started, let me introduce you to Slido. You can access this by scanning the QR code that you can see on screen or typing in the URL. You can submit any questions as we go throughout the session, and at the end, we will try and answer as many as we can. Any questions that we can't answer today, we will follow up with you all after the session and provide the answers to all of the questions submitted. So let's get started. In a moment, we will set the scene on accelerating the transition to clean energy. Then Dave and James will run through several live demonstrations focusing on planning development, site management and operations, and they will then be followed by Dom, who will share some fantastic examples from across the industry. So please join me in welcoming Dom.
Thanks, Jess, and good morning, everyone. Today, we're hoping to provide an overview of the many ways in which GIS can be used in the generation, storage, and distribution of renewable energy, and include an introduction to some of the companies that are pioneering the use of geospatial technology in this sector. We know that the UK's capacity to produce renewable energy is currently in the region of 43.9 thousand megawatts, when both operational facilities and projects under construction are taken into account. Onshore and offshore wind and solar power generation make up over 89% of this clean energy output. But other carbon neutral forms of energy like hydroelectricity, landfill gas, and anaerobic digestion are making a notable contribution. So geospatial technology has been used in the oil and gas industry for decades and is now proving pivotal for the expansion and development of the renewables industry. As you can see on the slide, it can provide critical location-based intelligence, allowing organizations to visualize, analyze, and share information about the locations of various elements. These could include resources, assets, constraints, competitors, markets, supply chains, and also risks. GIS can be used to overcome many of the challenges faced by the industry, not least the complexity of finding the best locations for new projects. Sites need to be identified where the conditions are right for generating or storing renewable power, but where impacts on the environment and local communities can be mitigated and costs minimized. Many renewable energy companies already use GIS in this way to inform site selection, but GIS can also add value beyond the planning phase. It can be used to enhance efficiency during development and build processes, improve health and safety and reporting at operational facilities, and transform communications with communities, stakeholders, and employees. It's used in a wide range of ways across the industry, and you can see here that there are a number of examples shown. We'll go into detail on the specific examples following the demonstrations we've got today, but just to give you a bit of an overview, a lot of the ways this can be used across renewable organizations includes understanding context and constraints, such as visualizing features such as flood zones to understand the wider environment, automating routine tasks, empowering field workers who can capture data out in the field, monitor progress through dashboards showing real-time energy production and storage capacity metrics, but also to look beyond the horizon by accessing data for live weather and traffic feeds. Hopefully that gives you a bit of an insight into the value that GIS can bring to the industry. Dave and James are going to bring this to life a bit more than me speaking with a series of live demonstrations to illustrate these key use cases. So Dave, over to you with an overview of ArcGIS to start.
Thanks, Dom. So as Dom says, before we start with the demo scenarios, I'd like to provide a high-level overview of GIS. This will support your understanding of our approach and offer a key takeaway. In a nutshell, the role of GIS is actually quite simple. It allows us to bring together multiple data sets that are important for our project through the common view of location. We're then able to visualize this data to gain new insight. And occasionally we might also run some analysis at this stage to generate new understanding. Finally, and this is really the important part of this section, is we want to share that information out with others in a way that is suitable for their needs. Whether you're engaging with stakeholders, field workers, pushing information out to the public, they've all got slightly different requirements. So whenever we build an app, we need to make sure it's tailored to their specific needs to make it simple and intuitive and easy to use. This is why at the end of each of these scenarios, me and James are going to show you a few examples of sharing so you can get a feel for some of the possibilities. So for the demos today, we're going to start with a few scenarios around planning and site selection, and then we'll cover site operations later. Now I want to start with wind farm site selection. And for this, we're going to take a variety of constraint data sets, and we're going to combine them together to help us understand the ideal places for a new wind farm. I'm going to use ArcGIS Pro for this analysis, and this is the ideal tool for this sort of multi-step analysis process. I've already run most of the analysis, but I want to show you all the outputs to give you a feel for the entire workflow. So what we do is we start with an area of interest where we're thinking a new site might be appropriate, and then we want to bring in a variety of constraint criteria. Now, I'm only using a small number for this particular demo, but this could be expanded out to cover any negative or positive constraints that you want to use for your project. So for today, we've got sites of specific scientific interest, we've got special protection areas, we've got urban areas, other more rural addresses, and we've got roads. And when I visualize all these data sets, we're already starting to get a feel for where might make a suitable location. But there's one important analytical step that we still need to cover. So although we've got all these really interesting constraints, we also need to make sure that we're a significant distance away from them. We don't want to be putting turbines right next to a road or someone's residential property. Now for that, I'm going to buffer all these data sets, and each layer can be buffered individually based on the criteria that I think appropriate. So for example, on this case, I've buffered the urban areas by 1 kilometre because I want to make sure it's well away from urban locations. Whereas roads, I've only buffered by 200 meters. For all the others, I've buffered by 500 meters each. Now, as I said, all of these can be adjusted so you can fine-tune the process for your own requirements. What we can see now is a really good feel for what locations might be good. The problem is my data set is really focusing on the bad areas, and I want to flip it on its head to just pick out the ideal locations. For that, I'm going to take this data set and I'm going to extract it from the area of interest that will then just leave those selected locations. So this is giving me a feel for suitable sites. The problem we have here is there's quite a few of these, it's just simply far too small. So I want to filter this down to just show the areas that might be appropriate. So there we have it, a fairly simple process to take a variety of data sets to drill down onto the key locations that are going to be good for a wind farm. Now, this is only a demo just for the purposes of today, but I have brought in some real wind farms, and we can see here that we've actually done a fairly good job of predicting where these wind farms might be found. Now, before we finish up with this scenario, there's a couple of other things I want to cover. The first is automation. Now, it might be that we want to rerun this scenario on multiple occasions. It might be we're looking at different areas. We want to perhaps tweak the criteria to look at how different outcomes are generated. And so this is where Model Builder comes into play. This is a great environment for building our own tools. And what we take is a series of individual analysis steps and combine them into a workflow. So what we've got here is we've got all the input data sets, we're buffering them, merging them together, erasing it from the AOI to create a new data set that we're then selecting down to just the right locations. So we've got that complete workflow in one tool. Now, when I run this, I've designed it so that I can change many of these parameters at runtime. So I can tweak the settings for my buffers, perhaps adjust the data sets so that I could share this with colleagues and they can run it for their own tasks. It also makes it really, really easy to use. So I can take my understanding of GIS, combine it into a model that I share with colleagues who perhaps might be not quite as technical, but they can run this process and add it to their map. So Model Builder really is a powerful tool for automation on repeated tasks. The final step I want to cover is sharing and collaboration. I touched on that at the beginning. So once we've done this analysis, we want to share it out with a wider community. So for that, I want to show you this really great story map. So story maps allow us to bring together maps, charts, graphs, images, videos to create a really engaging narrative. Now, this was produced by one of our customers and is a really great example of how they've produced a story map for public consultation. Now, the reason I like this is because there's so much information here, but it's simple and easy to follow. I can understand all aspects of the project, or I can just jump to the bits that interest me the most. It might be I want to understand the benefits of the proposal, look at the environmental impact assessment, perhaps understand how they're going to address some of the wildlife and habitat worries. I particularly like this landscape and visual section because they've used GIS to do a viewshed analysis, which they're showing here. But further down, they've got some really nice swipe images so that we can see the before and after scenes as to how this site might have an impact on the environment. So story maps are a really great way of engaging with an audience so they can follow through your process and understand your project in detail. So hopefully you found that an interesting overview of wind farm site selection. I'm now going to hand over to James, who's going to still cover site selection, but with a more urban setting. So over to you, James.
Thank you, Dave. So as Dave said, let's think about site selection in a more urban example. Electric vehicle charging points is quite a topical example at the moment. And just this week, new legislation was announced by the government to make it easier to access public EV stations. So in this scenario, I'll imagine I work for a company who are planning new charging points in Southampton. And let's say I'm tasked with finding the best 5 locations for new charging points. Thinking about lots of different requirements such as demographics, demands, and physical constraints such as pavement width. So this is my area of interest in Southampton. And these are all of the possible locations for our new charging points. So I guess first we should think about where the existing charging points are, because our charging points shouldn't be too close to existing infrastructure. So the existing charging points are shown here with a 500-meter buffer. So I guess what we can use some geoprocessing tools to remove all of the potential locations that are within that buffer. So next, let's think about some of the physical constraints. And as an example, let's say that we shouldn't build a charging point on a pavement that's less than 2 meters wide. So to do this, we can use some pavement width data. Esri UK supply that, which has a UK coverage and is split into different categories for less than 2 meters, 2 to 3 meters, and 3 meters plus. And if we just home in on a small area, you can see that the less than 2 meters is shaded in red, 2 to 3 meters in yellow, and 3 meters in green. So by using a spatial join, we can link the pavement width and the street name to the possible locations. So the next thing we should do is filter down the locations that don't have a suitable pavement width. And we can do that with the selection tools here. Now we have a set of possible locations, but we need to think about where the demand actually is. So to do that, let's look at where the EV owners are in Southampton. And this is everyone outside of that original buffer. So what we'll do is run a tool called location allocation to decide the top 5 charging points based on the demand in the local area and also the possible locations. So that looks something like this. And what we're doing is creating these top 5 locations for EV charging points. And the symbology here is proportional to the demand for each charger. So it looks like there's quite a large demand in the northwest, and we might need to provide multiple charging points at that location. So hope you can see that with just a few simple geoprocessing tools in ArcGIS Pro, we're performing some quite complex analysis with lots of criteria to identify new charging locations. So far you've heard about some of the ways GIS can be used for planning and development for wind farms and EV, and now we'll move on to think about solar. I'm going to show you how we can estimate the solar potential of a neighborhood in Washington, DC in the US. And actually this example is taken directly from the Esri Learn website, and we'll make sure we send out a link after this session if you'd like to have a go for yourself, either with your own data or with the example data. And we'll use a set of analysis tools available in Pro with the Spatial Analyst extension. So what you can see on screen here is a digital surface model, which is created from LiDAR surveys. And like I mentioned, this is in the US, but there's lots of open source LiDAR available from sources such as the Environment Agency, as well as premium data sources such as Blue Sky. I also have access to the building footprints for our area of interest. And first thing I did is run a tool called Area Solar Radiation. What that does is use a sophisticated model that takes into account the position of the sun throughout the year, as well as the obstacles or slopes that will obstruct the sunlight throughout the day. And all you need for that is the digital surface model. And we're using our building footprints as an extent. So we can create something like this. Each cell value is the amount of solar radiation in kilowatt hours per square meter throughout the year. So to identify the suitable rooftops, we're going to use 3 criteria. A slope of 45 degrees or less, so we'll need a slope layer for that. Rooftops with at least 800 kilowatt hours per meter squared of solar radiation. And also rooftops that don't face north, because north-facing rooftops in the northern hemisphere receive less sunlight, so we need to use aspects to do that. Just zoom in on an area to sort of provide a little bit more context. So first I've removed the solar radiation layer to show the rooftops with low slope. Next, removing the areas that, the low slope areas, and actually what we're seeing here is rooftops that have low slope and high solar potential. And then here, removing more criteria to show only the rooftops that do not face north. And all of this analysis is done using the CON tool, which is a raster analysis tool that uses if and when conditions to create raster data. So next we'll use the zonal statistics tool to aggregate the average solar radiation and assign the average yearly radiation to each building footprint. And for this analysis, we'll say that if a building has less than 30 square meters of roof surface, of suitable roof surface, it's generally not suitable for solar panel installation. We can filter the buildings using the Select by Layer Attributes tool and extract the buildings that fit this criteria. So shown in red are the suitable buildings identified by this tool. And I open up the attribute table. I can see that the usable solar radiation and the potential electricity production measured in megawatt hours for the year. So this is our final results, our final map, and we're visualizing the final results based on the potential electricity production for each suitable building. The darker colors show buildings with high potential. But a nice way to share this is via a 3D web scene, which is a web-based application that can be shared to the public or other stakeholders. So in this example, we're estimating building heights using the DSM from earlier on. And using a web scene allows us to do things like add date and time enabled shadows. And to put the visualization in context, in 2019, the average household in the US consumes about 12 megawatt hours per year of electricity. And I can do things like query an individual terraced house and see what the solar potential is. So, for example, it seems most of the suitable terraced houses in this area can produce just under half of the electricity needed for the year. So I hope that gives you an insight into the capabilities of ArcGIS when thinking about planning and development for renewables. We're now going to change tack and focus in on site management and operations with a demo led by Dave.
Okay, great. Thanks, James. So what I'm going to do now is I'm going to show you how we can use ArcGIS for site operations using a wind farm, totally fictional, that I've built on the outskirts of Aylesbury. What you can see here is we've got some really interesting data sets, a mix of natural environments such as the hedgerows and biodiversity improvements, but we've also got the solar panels and other equipment. So what I want to show you for this session is how we can use this information to share it in a variety of different ways. So the first one is fairly simple. In this example, very similar to the wind farms, we want to share and engage with the public. So this is a nice simple map that shows key features around the biodiversity improvements we're making across this site. Now this could easily be embedded in our website or shared via social. The next example is also a biodiversity focus scenario, but this time we want to understand the distribution of endangered or vulnerable species across our site. So we've got a really nice dashboard here that's very much focused on that particular issue. We've filtered out some of the solar information because we don't need that for this. But here we can see the number of vulnerable species that I've seen over the last month, their health, and the good news is most of them are healthy. We can see the distribution over time, we can see the types of species. So at a glance, we can get a really good feel for the animals or birds that we're seeing across this location. Now, the best thing about this is we've got this map in a dashboard, but I can also share this with my colleagues in the field so they can submit information about the sightings they see. So for that, we're just going to quickly drop over to my phone. And I'm going to open up survey 123 here, and we've got a vulnerable species survey, which is a fairly simple survey because we just want to capture some basic information. I can choose the location of the sighting. So this will open me up a map that shows my site. So I can choose a location. So let's put it here. I've then given myself a drop-down list of the vulnerable animals that we want to record. So this is entirely tailorable to your own requirements. But let's say we've seen a hedgehog. I can then choose a pick list of the number of hedgehogs I've seen. I can choose their health status, because obviously we want to provide an environment that encourages healthy and animals which have got a lot of well-being. And then it's automatically picked up the data for me. I can put additional comments if I wish, or if I'm lucky enough, I can capture an image of the animal to share with the team. Once I've done that, I can submit that. And what we'll hopefully see is in the background, my dashboard will dynamically update after a few seconds to see that feature. So that's a really nice thing about ArcGIS, is because we're all using one underlying data set, it allows me to collaborate on projects, and as the data changes in the background, it's reflected across the system, whether that be in the field or in this dashboard. Another very similar example, but this time focusing on maintenance, is we've got a dashboard here that allows me to understand the maintenance schedule of all my physical assets. So it might be that I want to inspect each of these features every 6 months. So I've got a dashboard here that's helping me understand, okay, well, which of my assets are due an inspection, which are slightly running behind, are overdue, and also which of my assets are currently offline. So again, at a glance, I get a very good feel of the operation of my site. As before, I can share this with my colleagues in the field. And this time I'm going to be using field maps. And the reason I'm using field maps is because I want to be able to access the actual information so that I can update it. It also allows me to see the site plan on my device. So I can freely navigate around this site. I can choose any particular feature. So we've got one here that's offline. So it might be that I've just done some maintenance work on that. It is now up and running. So I can see the current status. I can very easily edit that. So I can say, okay, well, this is now operational and it was last inspected today. And I can update that feature. So not only will it update on my display, we'll also notice that behind the scenes, that's updated on the dashboard. So it's really easy to get information out to field workers so they can capture information and return that back to you in the central office. So before I finish up, I just want to review what we've just seen there, because it ties back to one of the first statements I made, is we've started off with a site plan with some really interesting information, but we want to share this with different audiences in ways that is appropriate for their own specific need. So I couldn't give this sort of data to my field workers because it wouldn't give them the right access they need. So it is important we think about the communities we're engaging with and give them an experience that's tailored to them. So hopefully you found that really interesting. It's been a good variety of demos to cover a wide variety of areas. But just to reinforce some of these ideas, I'm just going to hand back to Dom, who's going to talk through some real life case studies.
Thanks for that, Dave. That was great. I still can't believe that we've got pavement width data. It always amazes me. So thanks for that. Yeah, so we've covered a variety of demos, and I hope these have provided a bit of inspiration about the possibilities of what's achievable with GIS. And as Dave said, these examples are inspired by the great work our customers are already completing. So to round out this part of the webinar, I'd like to reflect on the areas we've discussed by covering these case studies in a bit more detail. And the first one you can see on the screen here is Statcraft. Dave showed us initially the example of wind farm site selection and how using multiple input criteria can establish the best locations, which links really nicely to the team at Statcraft and the newly formed team, should I say, of professionals there, who are using Esri's ArcGIS technology primarily to help identify potential sites for onshore wind farms. They draw on a vast amount of environmental, historical and landscape data, conducting multi-criteria analysis of the UK to quickly identify and shortlist locations. They also use it to improve efficiency and collaboration during the development phase. By producing web apps, it gives them a bit of focus around relevant and accurate data in both 2D and 3D that they can then view and edit in the field, which accelerates the delivery of projects and will help the company to achieve its goal of creating 1.2 gigawatts of wind power in the UK by 2030. The next example, which James said was a more urban example, was around EV site selection, which can include the inclusion of demand modeling. And the example we've got here is with Osprey Charging, who are the company behind one of the largest and fastest growing networks of rapid EV charge points. And they've recently expanded their use of GIS. They're using the online solution as a means of making accurate, up-to-date data easily accessible to all employees, whether in the office or using mobile devices in the field. Previously, they create bespoke maps on demand whenever they were asked. However, now what they're doing is everyone in the business can self-serve from the maps and the data that need direct from the viewer aspect of the ArcGIS platform. They consequently save up to 5 hours a week, enabling the time to be spent more analysing the best locations for the installations, which supports the plans to accelerate their rollout of new charge points. So you may see those out and about. And I suppose for the company, the wide use has opened up data that people previously couldn't see, and they've given everyone in the business a bit of an improved understanding of all active and planned charge points from Inverness in Scotland right down to Cornwall. We then looked at how you can understand the potential of site locations and maintenance for solar. It was great to see how, you know, a similar problem but have differences that can be applied. I particularly like the 3D model of the households and seeing the shadows example throughout the day. You can kind of very quickly see the advantage of what having that information readily available will give you. And that brings us on nicely to the final case study I've got here, which is with GABM Solar, who the work they've done significantly reduced the time required to identify suitable land. For large-scale solar projects, it's reduced, they say it was from 5 to 10 hours to 5 to 10 minutes, which is a significant reduction. Again, using ArcGIS, they built a bespoke site searching model that automatically qualifies and highlights viable land parcels with designated distance from a substation with the availability grid capacity. So what that means for them is they can now focus on sites with the fewest potential planning constraints and conduct detailed feasibility studies. They also use story maps, which we've shown there, to improve the quality of public websites and consultations and allay any concerns people may have. It's a really nice way of presenting that information. And what that's meant for the business is they've secured planning permission for over 98% of the projects they've worked on. So a really nice achievement there. So what I'd like to do now is we've kind of been mentioning it throughout is bring to the questions and answers everyone's done. I've seen them coming in as we've been going on. So thank you to everyone that submitted those. If you haven't had a chance to submit a question yet, please use the QR code to do that. We'll if any we don't get to today, we'll be sure to get them as part of the follow-up from this session. But if there are any questions you can see there, remember you can upvote them and we'll answer them based on the number of upvotes. So yeah, I think James, Dave, are you happy to turn your cameras on and I'll bring up the questions and we run through those? So I think, Dave, this one's probably best for you. For the wind farms, does Esri provide data sets to support this type of analysis?
Yes, yeah, we do. So we've got a online repository of data called the Living Atlas, which is available to all of our customers. And that contains many great data sets, often provided by Esri UK or our colleagues in the States, but also includes a lot of data that's supplied by our customers. So the Environment Agency, DEFRA, ONS, for example, are all good examples. So you can find many of the constraints through that environment. So SSSI, special protection areas, urban areas, they're all available in the Living Atlas. So certainly that's a really good place to start. And then there will be some limitations there. You know, you might not be able to find every individual property. So that's when, you know, reach out to us and we can tell you about more private data sets that perhaps can be bought elsewhere.
Great, thanks for that, and thanks for that question. Next question is, does the data in a story map need to be shared publicly? If I want to share a story map with my client and not the public, how can I do that? Okay, well, I'll take that one as well. So it doesn't need to be public, no. So you can have a story map that is entirely internally facing. So it might be that you want to talk about the project within your own team or share it across your organization. If you want to share it with the clients, then you'll need some way of them having their own ArcGIS Online license so that you can share it with them, because the whole concept of ArcGIS is built on named users. So if they've got a named user and you've got a named user, then you can collaborate between the two of you through groups. So yes, that is entirely possible. Great, thanks, Dave. Do you have any analysis slides or run-throughs on site selection for large industrial scale ground-mounted solar farms? Ooh, I think we will. That is one that I think we should follow up with, though, and rather than make everyone sit and run through that. Thanks for that question, whoever that was, anonymous. We will follow up with that after this. So
I think there are some tutorials on the learn.arcgis site that talk through the basics of site selection, but something on a much larger scale. Then yeah, we'll need to follow it up. But there are some of our customers that have multi-criteria analysis that's using hundreds of data sets, and they use Model Builder to address that. So it's certainly possible. Whether we've got any slides ready to go is a slightly different question.
I've put a link to another webinar that Esri did back in 2020 that should cover some of what you're asking for there. So it'd be worth having a watch.
Perfect. Thanks for that, James. Dave, I think this is another one for you. It's about wind farms again. Thanks, Henry, for the question. Can you incorporate turbine height into the viewshed analysis?
Yeah, so shall I actually, Henry's got a couple of questions there, so I might address them both at the same time.
Yeah, that'd be great.
So so viewshed analysis, yes, is very similar to ZTV analysis. The idea is that you take some sort of underlying terrain data set, and then you can also have other data sets such as buildings like James showed. You can have 3D buildings, you can have trees, bushes, whatever is going to restrict the viewshed. You can then run analysis that defines, okay, well, take into account that terrain, all of those features, how far can this particular object be seen from? Now, you can either do that at ground level, or you can define a height for the feature. So obviously turbines are quite high, so you can define a height for that turbine. I would typically probably run the analysis at multiple different heights, so the top of the turbine, the middle of the turbine, at the bottom, because then you can understand, okay, well, the top might be seen across this area, but the majority of the turbine can't be seen nearly as far. So you could run it at multiple different heights. So hopefully that addresses both of those two questions.
Thanks for that, and thanks, Henry, for your questions. The next one, is there an industry standard or specific rule law on the buffers from residential areas to these developments? That could be applied to any of them, really, couldn't it, Dave?
Yeah, it does very much depend on the size of the turbine, because it does vary depending on the size. There have been discussions even in Parliament about the rules around this. So I can't give you a definitive answer because it does depend. But certainly, you know, there is lots of great information online around the official laws, and it varies country to country, turbine to turbine. But there are some specifics to help guide you in the right direction.
Okay, thanks for that, Beth. James, this one's for you. How did you calculate the estimated yearly solar power production?
Okay, yeah. So what we did to calculate well, it goes through it in the tutorial, but you take the mean solar radiation for each rooftop and then use a couple of different constants. So there's one which is efficiency and one which is performance ratio. And I think in the example it was 16% efficiency and 86% performance ratio. And you can use the calculation tools in ArcGIS to create new fields with those statistics in.
Okay, great. And then how can access to the solar maps and apps be controlled?
Okay, well, I guess if we talk about how apps and maps can be controlled in general, because it's the same sort of process across the board. So I talked earlier about ArcGIS is underpinned by named users. So the importance of that is it allows us to to a great degree, control exactly who sees it. So when you've created an app, you could say, okay, I want this to be the public, and then you share it publicly and anyone can access it as long as they've got the URL. Next step down is, okay, I just want to share it across my organization. So that means it doesn't go outside the business, but everyone within your own teams can see it. Mm-hmm. Or you could just say, okay, I don't want to share it with anyone. So it's just managed by yourself. And I'd recommend that when you're first building a project, you don't want people looking at it before it's finished. The final thing is we can use groups, and groups allows you to define exactly who is going to see this particular work. And that could be a group of people within your own organization, or you can invite people who've got ArcGIS Online accounts or from elsewhere. So you can collaborate across organizations as well. So there's a lot of control there as to who can see what. and who can do what. So do you want them to be able to just see it, or do you want them to be able to edit it as well? So hopefully that answers that question.
Perfect. Also on wind farms, can ArcGIS Online be used in place of Pro for analysis?
Yes, but at a much reduced capability. So Pro really does provide a wealth of tools for doing this for analysis. You could use ArcGIS Online because ArcGIS Online does have analysis tools. So you could run the buffer, you could merge all those data sets together. You could, I believe, then extract that out from an area of interest. So you could do a simplified version. It doesn't have quite the same automation tools unless you're happy to do a little bit of scripting, because we can use notebooks to script things. So the answer is yes, but I personally would always choose Pro because it just provides so much more capability.
Okay, great, thank you. Can VR be integrated into site selection? I'm involved with BESS and PV sites. Site examination with 3D VR would be useful.
Yes, absolutely. And in fact, one of my team has recently created a really nice VR environment where they're looking at existing infrastructure in a site, both below ground and above ground. So you can put on a VR and you can see where all the pipes and underground network are, because you're seeing through the ground, but you can also visualize, okay, what might a new site look like? So that might be a new building, a new turbine, new equipment, because then you can get a feel for, well, how is that going to fit into the existing environment? So yes, absolutely.
That sounds really interesting. And we've just had one pop to the top there. RE Wind, is there any tool in ArcGIS to measure the wake effect direction?
That one I don't know. So
Yeah.
do you mind if we get back to you about that? Sorry, I haven't got an answer straight away.
That's fine. That's fine. What data set is containing pavement width? Yeah, I like that data set.
Okay, well, I think there was a couple of questions actually about pavement width, because there was one about, is it open data? Okay, yeah, down a bit. So on both those, so the footpath width data is not open because it's based on master map data. So master maps provided by the Ordnance Survey, and public sector organizations will get that for free as part of the PGSA. But for commercial organizations, it does have a cost. So probably the best thing is, if that width data is interesting to you, then reach out to us and we can advise about how you get access to that and how much that might cost.
Okay, great. I'm conscious of time here, so we'll answer a couple more. Thanks for all the questions. It's always really good when you get lots of them, so thank you for that. We'll just have a few more, Dave and James, and then I think we'll hand back over to Jess. So this one's come to the top now. Is it possible to set up access to ArcGIS via single sign-on from a client's Azure AD environment in the cloud?
I mean, James, feel free to jump in here if you know more than me. So single sign-on, absolutely, that is supported. So you can use your organization's own internal login infrastructure to support signing into ArcGIS. I'm just not sure about the Azure bit. I guess so, because we do support AD. I just don't know specifically about the Azure section.
Yeah, we do support Azure AD as a IDP for ArcGIS Online, so you can use Azure AD as a client.
Okay, great. Thank you for that. In the solar potential demo, how did you add shadows to the 3D scene?
I'll see if I can demo this one really quickly. So in the solar example, we're using a 3D instant app called 3D Viewer, and in the config of that instant app, in the interactivity tools, you have the option to add daylight animation, and we have that tool opening from the start. You can do things like setting the date and the time, so that the shadows are representative of that particular location and that particular date.
Looks great, doesn't it? I like that. Right, let me pull these back up. We'll do two more, and then we'll answer the rest in the follow up. So we've answered that one. I'm interested, please, in which mobile devices can be used to support field work.
Okay, so if you want to use our native apps, then we support Android and iOS. So field maps, Survey 123 will both work on either of those environments. If you have a different type of device, then you can still access things through the web browser on your phone. It just limits you slightly on the capabilities of, particularly around offline, but you can still access the content, you can still update the features through a browser.
Okay. Which network datasets were used to find the best EV charge points?
Yeah, so we use the OS master map highways to do that analysis. My understanding is that you can use the road network that's in ArcGIS Online. It would just be a credit consuming tool. So there's lots of different ways you can do that. We used a premium data set, but you can use the Living Atlas as well.
Okay. We've got 3 left. Should we quick fire these as fast as we can? We might as well. Where do you get the underlying data sets from?
Okay, well, as we talked about earlier, a lot of these are available already in the Living Atlas, so they're just available for people to use. The other data sets that are a bit more premium are, we used some building outlines, so that would be from Ordnance Survey. I showed some residential addresses, that would also be from Ordnance Survey. So it's probably Living Atlas and Ordnance Survey would cover most bases, I think.
Will you be sharing the recording of this webinar? Yes, we will. So everyone who has signed up for the webinar, and even those that haven't attended, will be sent it. So if you've been scribbling down notes for a colleague who's not been able to attend, I'm sorry, but you will get the full video recording of this. So yeah, that'll follow after this. And I believe we covered the footpath data actually, didn't we?
We did do that one.
So yeah, thanks both for answering those questions. Thanks everyone that submitted one. You can still see it on the screen there, and we'll answer them following this session. So if you do have any off the back of the questions we've asked, submit those, and we'll get back to you on them. So thanks both, and I'll hand back now to you, Jess.
Lovely, thank you very much, John. So there's a number of fantastic resources that we've mentioned today, and you'll see these on screen, and you are more than welcome to download them by using the QR code. Please don't worry though, we will be sending the link to you in our follow-up. Just to highlight a couple of examples that are really interesting, there's a great article on how renewable energies companies have applied location technology in recent years and how it might help them power tomorrow's high-profile businesses. There's also a fantastic tutorial that James actually mentioned, so I thought I'd plug it here as well, where you can use ArcGIS Pro to determine how much solar radiation each rooftop receives throughout the year. And you'll also be able to estimate how much electric power each rooftop could generate if they had solar panels. So a great tutorial if you want to get involved. And again, we'll be sending you all the links to these as well. Hot off the press, we've just launched our free ebook entitled Accelerating the Transition to Clean Energy. I thoroughly recommend checking it out if you'd like to explore more real-world examples from around the UK. You can see on the slide the logos of some of the renewables businesses featured in the ebook, and it's a great opportunity to read their stories and understand what they've achieved. It's certainly a great read, and you can download it again by using the QR code, but we'll also send it to you in the follow-up, so no need to rush there. So if you'd like to get in touch with us following the webinar today, then please do. I've included Dominic's contact details on screen now, and you're more than welcome to give him a call or send him an email following the webinar today. He's happy to help. It will also be lovely to connect, so feel free to connect with all of the team on LinkedIn. It will be great to hear from you all. And finally, I just want to say I really hope you've been inspired by what you've seen today. And I hope that this has inspired you to really want to see more in terms of applying GIS to your business and the positive outcomes you might expect. It's been great having so many of you join us today. Thank you for submitting all of your questions too. I hope you have a great rest of your day, and we will see you all again soon. Thank you very much, everyone.